for the evening is that we have Jeremy French as our main keynote speaker, and he'll talk. I'll introduce him in a minute. And then we've got 3 homeowners who'll all speak briefly, and then we'll have time for questions. And then Peter Burgess-Allen from March's Energy Agency wants to have a short slot.
Hello, Peter. Hi.
And and then we want to mention at the end about people willing to open their homes and any other practical things. And if there's interest, we can go on till 9 o'clock. But if there isn't, it says my internet's unstable. You might not be able to hear me at the moment. Hopefully you got the gist of what I'm saying. So if we can go on till 9 o'clock, but if we're running out of questions, we can finish a bit earlier than that. I'll play it by ear. So I think we mute everyone now, Julia, and then ask Jeremy to, no, I'll introduce him and then ask him to unmute.
Okay.
So, welcome to Jeremy, who is the technical sales advisor for IMS Heat Pumps. And going to talk to him seems a very useful and practical thing. So welcome, Jeremy.
Thank you.
You've got your slides ready to share screen?
Yes, so hopefully this will work.
And if not, I can do the PDFs, but I think the real slides are probably better, so go ahead.
Okay, let's see if this works then.
Yes, that's showing.
Yep. Okay, great. So, yeah, I'm Jeremy French. Move that. Can you see that all right? I'm getting a toolbar across the top of the page. There we go. Okay. Yes, I work for IMS Heat Pumps. We are independent installers of ground and air source heat pumps. The company was established by, Alan's just retired a couple of weeks ago. Alan Donald in 1997. He was one of the first heat pump installers, certainly of any sort of numbers, in the late 90s. And we've been installing, as I say, ground and air source heat pumps, water source heat pumps for, well over 20 years now. We've got offices in Sheffield and Perth. We also install heating systems, underfloor heating, radiators, and the hot water system. So we do everything on the heat pump and heating side of things. I started my heat pump career in 2007. I've worked with various manufacturers and installers over the years. I joined IMS in 22, though actually a lot of the people I work with go back to the Eco Heat Pumps days in the early 2000s. So yes, today I'm going to be busting some heat pump myths. There's quite a lot of misinformation and contradictory information, particularly on the internet. We quite often at exhibitions get asked a lot of the same sort of questions about what heat pumps can and can't do. So the aim of the presentation is just to run through some of that and hopefully dispel some of those myths and get to the bottom of what heat pumps are all about. So this is probably the most common query we have, or misconception that heat pumps are noisy. I'm hoping everybody's audio will work here. This is a little case study we did in Sheffield. So I will just let this play. if you can't hear it, please pipe up and I'll try and get it working. But here we go.
Have you ever wondered how loud a heat pump is? Well, today we're going to find out. We've brought a specialist piece of equipment to measure the sound, which will measure the decibel level. So we're hoping that we can dispel that myth that heat pumps are noisy. It's actually working right now, and I can't really hear it. How loud is the heat pump?
So yes, I installed my air source heat pump about 15 years ago, which is a very old generation of machine. Has a huge air handling unit outside, and compared to modern heat pumps, is relatively noisy. However, these days, typically the sound power output is somewhere between 40 and 60 decibels, which is rather quieter than a gas boiler. The flue of a gas boiler. Heat pumps are required to meet certain sound level requirements for permitted development. The background noise we have to achieve at the nearest neighbour's window is 42 decibels, which is comparable to the sort of background noise you would have in a library. So actually very quiet indeed. Modern heat pumps have a lot of acoustic design gone into them in terms of the fan and the grills and the compressor housing. So they are certainly designed with noise levels in mind. One of the common sort of queries we get, or people are perhaps reluctant to put a heat pump on their patio because they don't want to be disturbed when they're sitting out enjoying the sunshine. I've actually got my heat pump on the decking in the back garden. And when the weather's nice enough for me to be sitting out enjoying the sunshine, the heat pump is well, not really doing anything. In warm weather, the heat pump is largely not going to be operating, potentially for hot water. And when air temperatures are warm, heat pumps tend to work at a very low level. The fan speed will be at its lowest setting. So they very, very rarely create any sort of noise input in that respect. If you had a heat pump installed outside your living room window, certainly if the window is shut, it's extremely unlikely you'd be able to hear the heat pump inside, because, as I say, they are certainly the modern machines are very quiet indeed. Quite often at exhibitions and trade shows, we'll have a heat pump running. And we can be talking to prospective customers, and people will ask, well, how noisy is the heat pump? And you can say, well, it's been running all the time. We've had this conversation, and people don't even notice with the background noise in an exhibition hall. So they are very quiet. Heat pumps, well, it seems a bit paradoxical that you can produce heat from the outside air when it's very cold outside, but you can. Modern air source heat pumps are extensively tested. Most manufacturers these days have quite sophisticated climate modelling facilities. I worked for a manufacturer who used Volkswagen's climate center in Germany to test their heat pumps. It's quite expensive to design and develop a heat pump system, and if they didn't work when it was cold, they wouldn't sell. So it's a pretty straightforward sort of commercial decision. Most heat pumps these days will operate down to -20 or even -25 degrees C. The core of the system is a refrigerant circuit. The refrigerants typically boil at about -40 or -50 degrees C. So even when it's -20 outside, the air temperature is still 20 degrees over the boiling point of the refrigerant. so you can evaporate that refrigerant and get the whole heat pump cycle working. One thing to bear in mind is that at colder temperature, the output of the heat pump will generally fall off a little bit. It does depend on the make and model of the heat pump. Heat pump manufacturers don't always help themselves in terms of their naming of products. And one manufacturer produce what they call an 8 kilowatt heat pump. At -3, it can produce 6 kilowatts. And another manufacturer who produces 7 kilowatt heat pump, and at -3 outside, that can produce 8 kilowatts. So as an installer, you have to understand the machines and their performance at different temperature conditions. We do very detailed heat loss calculations for each and every installation that we do. We use industry standard weather data from the Chartered Institute of Building Services Engineers. It's used throughout the building services industry. So we have weather data for many locations all across the country. We also compensate for the altitude of the building in question. As you get higher above sea level, the average annual temperature diminishes, so we can say with good confidence what the critical design temperature is for a given building in a given location. And then with knowledge of the correct machines to suit that property, we can make sure that we provide, indeed we are required by the microgeneration certification scheme to provide 100% of the heating load at the design conditions for that particular building. But yes, some competency is required in terms of training and understanding of the machines. These are a few examples. These are 3 of our staff heat pumps in Scotland. So this is showing the indoor temperature inside the little gold house and the corresponding outdoor temperatures. So these are just some examples of working heat pumps, keeping buildings at the desired internal temperatures when it's pretty chilly outside. Perhaps the most interesting slide to illustrate the point that heat pumps work in cold conditions is this next one. This is 2022 data from the European Heat Pump Association showing heat pump uptake throughout various countries in Europe. And as you can see, the top 3 heat pump installers are Sweden, Norway, and Finland, who have considerably harsher winters than us. Yeah, they install lots of heat pumps, so I think that's a good illustration that the UK climate is not really a challenge for any decent heat pump installation. Another common misconception is that heat pumps will only work in new build properties. Again, not entirely true. We have installed heat pumps in all sorts of different buildings, Scottish castles. We've worked quite a lot with the National Trust, with lots of their old building stock, listed buildings where the potential for any sort of insulation improvements are pretty limited, and lots of very standard sort of 30s 3-bed semis, barn conversions. As long as we know the dimensions of a building and the fabric that it's made out of, we can calculate the heat load, and in most circumstances we can design a heat pump system that is going to meet 100% of that heating load. So you certainly don't need to have insulation in our property to keep it warm with a heat pump. The house doesn't know what's heating it, whether it's a gas boiler or a heat pump. And if the design is right, we can nearly always make sure that the running costs will be lower with a heat pump than a gas boiler or an oil boiler, for example. However, a fabric first approach is definitely a sensible one. If you can improve the thermal properties of your building in a cost-effective way, I would certainly recommend doing so, particularly in terms of laying mineral wool in loft voids. It's very cheap to do and can buy really quite good gains in terms of your thermal performance of the building, something up to sort of 20–25% potentially of your heat loss. So yes, an easy win. Things like floor insulation, solid floor insulation, may be much more difficult. I'll move on to my own property later in the presentation. I chose not to try and insulate the floors because it was going to be a huge amount of work. But yes, where you can improve the fabric, it's certainly money well spent. If you can reduce the overall heat load, you can reduce the annual energy costs. And if you are installing a heat pump, you can reduce the size and therefore the cost of that system. Heat pumps will work with radiators or underfloor or fan coils or pretty much any type of distribution system. We quite often are asked whether they will only work with underfloor heating. Underfloor heating is great with heat pumps because the surface area is very large, so we can run the system quite cool. But radiators can be sized perfectly well to run a heat pump system. It does depend on the radiators, though. If you have lots of the sort of 1970s and 80s single panel radiators as shown in the picture, certainly by now they're probably in a pretty dire state and full of crud and not very efficient. They have a relatively small surface area, which means you have to run them quite hot. And ideally, we want to run the heat pump system considerably cooler, because the cooler you run it, the cheaper it is to operate. So we can run radiator systems cooler by using more modern types of radiator with the fins inside, which increase the surface area, and mean we can run the system cooler. Just a quick example at the bottom there, the Valent aerotherm system, running it at 55 degrees C gives us a seasonal efficiency, a seasonal coefficient of performance of about 3.5. If we can reduce that seasonal flow temperature down to 40, you get a significant increase in the operating efficiency, so you pay less to run your heating system. So investing a bit in upgrading the radiators is definitely a good idea, but we have to take each project on its individual merits and weigh up the existing system. You may need to replace some of the radiators. You might be able to keep some of them, but we'd have to look at that on a case-by-case basis. Quite often we're told that heat pumps are expensive to run. If they are poorly designed, they can be. However, if a competent installer is putting the system in, they certainly shouldn't be. And it's not just about the heat pump, as I just touched on with the radiator slides. It does depend on the heat distribution system as well. I've got a couple of examples coming up. This is based on my own property, a very sort of standard mid-40s 3-bed semi, solid concrete floors. I do have cavities in the wall, but I got a chartered surveyor to come and look at the cavities. They're very irregular, and the sandstone that the property is made out of is very porous. So I was advised that it was likely that if I filled the cavities, that damp would bridge across and cause all sorts of trouble. So I haven't got any floor insulation, I haven't got any wall insulation, but I have got the loft insulated out and double glazing put in. My heat demand is a bit shy of 16,000 kilowatt hours a year. So that's what I've modelled these figures on. I've got two sort of scenarios here. The low efficiency reflects my current heat pump, which, as I say, is about 15 years old. Nothing like as efficient as modern heat pumps. And I'm assuming in this one, again, a low boiler efficiency. So we're not talking about a brand new boiler. But heat pump and boiler efficiencies broadly the same. that Scott of 3.3 on the left-hand side, that might equate to a new heat pump running hot on small radiators. Whereas if we look at the right-hand side, if we increase those radiator sizes, you can reduce your operating costs by something like 25%. So that's the sort of difference with the two green columns there between a relatively inefficient radiator system and one we've upgraded to run at lower temperatures. So going back to those radiator slides, it is generally speaking a good idea to try and improve that efficiency and bring your flow temperatures down. But a modern heat pump on good radiators, yes, you can reasonably expect about 4.5 units of heat out for every unit of electricity you put in over the course of a year. Now, this was based on Energy Saving Trust figures. You can see there for electricity at 22 pence a kilowatt hour, gas at 5.5, and so on. What we're seeing lately is energy companies becoming much more interested in heat pumps. So the likes of EDF, Octopus, and particularly OVO are now looking at heat pump tariffs. So OVO do offer a special heat pump tariff at 15 pence a kilowatt hour. At the moment, it's only rolling out with two manufacturers, Valent and Viessmann, but they are looking at bringing a lot more people on board in the next 6 months or so. But if we start looking at running figures at 15 pence a kilowatt hour, then you can see you can make some quite significant savings on the operating costs. A new efficient heat pump might cost you half as much to operate as a brand new boiler. So yes, heat pumps really shouldn't be expensive to run if they're designed and installed properly. And certainly if you can take advantage of the tariffs that's available, then they should be very cost efficient. And I think that takes me about to 20 minutes. I believe there's a Q&A session at the end, so we'll stop there.
Did you have another slide or two, Jeremy, or was that all you wanted? Oh, you're
Sorry, I
muted.
muted myself. No, that was it. I was a bit conscious of running over time, so I pruned it.
Well, that's all right, because we managed to start more promptly than I'd feared. So you could speak for another minute or two if you want.
I think I've covered everything, but I'm
Okay.
happy to do a Q&A either now or later if anybody's got any questions.
I will hold it because I've known when you start Q&A, it's hard to move on to the other speakers.
Fine.
So now let me check which order. Jon Whitley is next, and he's a homeowner in Edale. Would you like to introduce yourself?
I think I've unmuted. Can you confirm?
Yes, we can hear you.
I can hear you.
Perfect. Okay. Hi, my name is Jon Whitley. I live in Edale. I moved in about 4 years ago, about 4.5 years ago now. And we were quite lucky in that the state of the property, it was ready for quite a lot of work to be done on it. So we went in with a mission to upgrade it very much to be able to use a heat pump and to be fairly low need. We installed a Grant heat pump quite early on in the piece. I was again quite lucky in that a friend of mine is an installer for Grant, and he was able to allow me to do a lot of the legwork to get the thing ready and to prepare the ground, which saved me a lot of money. I also managed to get in at the end of the renewable heat incentive, so I got quite a big grant back for that. But notwithstanding, the property itself is about 200 years old. It's a gritstone, typical Derbyshire, 2-foot thick wall gritstone property. And our experience with the heat pump is it's absolutely fantastic. We've done quite a lot of work to the insulation, so we needed to when we went through the specification process with grants, they had a set of guidelines that they worked to, and I had to negotiate them back from that quite a lot, because I knew I was going to do a lot more insulation in the house, and I also didn't want to get the house to the temperatures that they were offering to work at. So I managed to get the frame size down one level after negotiation. They were very good about it. There wasn't any arguments or anything. They understood what I was trying to do. So it's quite good to bear in mind that you're the customer, and if you understand what you want, it's a very good thing to be able to discuss and negotiate with the people designing the system, because they have a set of pro formas. I'm sure Jeremy will confirm that he's got a set of pro formas that he works to. Now, that might not suit every person. Just pulling up our usage. The estimated usage from grants, they thought we were going to use a little over 7,000 kilowatt hours per year. Now, we actually use only 900, so it's only 1/7 of that on average in the last few years. So whether it's because we keep our house a lot colder than they thought we were going to, or I did a better job than I thought I did with the insulation, I don't know. I've just recently joined Agile Octopus, which has increased the amount of input that I have to make to the system, but it's allowed me a great deal more freedom to use the system when it's the most efficient to use it. I'm working on, and I'm sure there are a lot of other people working on, an app to interrogate the pricing and then to drive your heating system accordingly. So I think things are coming where it will make it even more efficient to use. If you can get on one of these dynamic pricing systems and you're able to move your usage around a lot more than perhaps just letting things run, there's a huge opportunity to make things a lot more efficient. We're part of the Eco Open Homes group, and we regularly have people come around and look at the systems. Most people are a little bit nervous, as Jeremy said, about the noise of the system. So it's great to be able to go in and view something working. And as he demonstrated, the noise of them is actually a great deal less than our neighbour's oil-fired central heating system, which is 100 meters away, and our system is only 10 or 15 meters away. So the noise is not an issue at all. And also you're in control of it. If you are sitting on your patio and you don't like the noise of it, turn it off for the time you're sat in the sunshine. That's about it. Yeah. So if you do want to come and have a look at the heat pump or what we've done for our insulation on a typical Derbyshire gritstone home, what can be done, please join in with the Eco Homes. I'm sure it's coming up soon. We'll be able to tell you about it.
It is.
Okay, that's pretty much it.
Great. Thank you very much, John. That's very succinct, covers a lot of information very efficiently. Thank you very much. So, Dave.
Okay. Yeah, we're ready to go. I'm scripted here, so.
And you've got some slides to show us.
Yes, I have at the end, just the last section. So yeah, I just set the scene. My wife and I are in our early 70s, and we live in a 1930s stone-built sort of semi. We had a boiler that was about 20-year-old, and we had some money. So about 4 years ago, and I've got an engineering background, so I was sort of looking at new things. We purchased an air-sourced heat pump, and I'd just like to run through the experience for you. I'll start with comfort. We've got as I say, a stone-built semi. It's got double glazing, cavity wall insulation. Pre-heat pump, we had a standard combi boiler. It's about 80% efficient, I guess. And we used around 12,000 kilowatt hours per year of gas, which is fairly standard, I think. The hot water for a start was slow to reach the taps, probably very inefficient, and it got very hot. You know, if you'd run at 65 degrees. The central heating was on timers. We'd switch it off overnight and it would get cold. So we had warm areas of the house, we had cold bits. Sort of post heat pump, we've now got a Valent Aerotherm plus 10 kilowatt air source heat pump. We've got a 200-litre hot water tank. It's at 50 degrees. I select the temperature depending on what we're doing, and it's much more comfortable for us. We've got plenty of water, and it's faster to get to the taps that we use a lot, which is great. The house stays comfortable all day and all night. We run it quite cold, really. I mean, about 18 degrees most of the time of the day, and 12 to 14, whatever we feel it at night. We've got no cold areas at all. It's a big improvement on comfort. We've got really good control over it, and it's very quiet. You know, as Jeremy said, we use about a quarter of the energy that we used with the gas boiler. So it's all good news. Space is the one that I want to show you some slides of, because there will be some problems for some people. With the gas boiler, it was a small gas boiler. It's hidden away in a cupboard under the stairs. And I just want to show you, I'm going to share there. We're going to share that one, which I hope you can see now.
Not.
Can you see that?
Not quite yet. Yes.
Yes.
Okay. Well, that's our airing cupboard. And it's very disorganized. You know, we are struggling with space, and the reason is that our huge double airing cupboard that we had now has quite a bit of equipment in there. There's a 200-litre hot water tank. There's two heat exchangers. We've got a couple of buffer tanks. We've got a hydraulic controller up here, and there's a lot of equipment. So, this is a 10 kilowatt unit. It's a very sophisticated Aerotherm Plus, and not all heat pumps have this much equipment. But you've got to bear in mind that there will be some requirement for a controller panels, you know, a large enough tank to be useful for a family, and some heat exchangers. Okay, and we do have the space. So outside, as Jeremy's already shown you, it's a fair size unit. And if I lived in a terraced house, I might struggle to get the 2 meters separation that I need. So I'd have to be very careful where I put it. And I guess there's some terraced houses just don't have the space. So that's one area. The other one is the radiators. And we insisted on this huge radiator in our hallway against, you know, I had to push for it. And it's a very valuable thing for us because it heats centrally the whole of the house. And we don't really have heaters on up, you know, the radiator's turned off most of the time, and we still achieve a good temperature easily. So you do need, there's about 30% efficiency compared with our old system. Gas temperature coming in was about 70 degrees. With our heat pump, we've got a flow temperature set at about 45 degrees. So these radiators are 30% as efficient at 45 degrees as they were at 70. And that's why we insisted on having larger ones, and they work very well. And the hallway is you know, sorry, the lounge is very similar. We've got a couple of larger radiators than we would normally have, but we're very comfortable. So There we have. And I'll stop sharing now with that. And okay, I think I can stop sharing. How do we stop share?
There's a red button.
Right, I found the red button. Yeah. Now, just finally, I've just talked to you about costs. Our initial installation costs were high, about 13,000, but we get back 11,500 via renewable heat incentive. And there are now other incentives which are coming. The running cost is very similar to our gas boiler. The heat pump is 4 times more efficient, and the gas prices are 4 times cheaper. So we find it's similar. But the major difference, huge difference, is the fact that because we're all electric, we can find ways to get low-cost electricity. You can't get low-cost gas. And I run my house completely off my electric van, my electric vehicle. I'm on a pilot study with Western Power, and my bills are half of the average. I'll probably pay about £800 a year to be comfortable all year, and it would have been 2,000. So if you're all electric, you've got a lot of opportunities with batteries and with electric vehicles coming, vehicle to grid, sort of charging and storage, and solar panels. Lots of ways. Community energy projects are coming. So I just say all electric is good. So, and that's it.
Thank you. Interesting. Really was.
Okay.
Indeed. So then our third person is Peter Gilbert.
Right. Yeah, can I just say, Zizi, that because Peter's only got a phone, he will need you to show his slides, and he has sent them to you. That's correct, isn't it, Peter?
It is, yes.
Yeah, okay.
Okay. Let me just open
Oh.
them. Do you want me to share the screen immediately, or?
If that's possible, Zizi, but if it's difficult,
No, it's
I can
okay.
start.
Right. No, I have to work out how to.
I think if you click on the slideshow at the top,
Just
will that
show
work?
it full screen.
Slideshow, can you? Or
Oh, yes. There we are. Thank you very much, Julia. That's useful.
Great. Can everyone hear me okay?
yes, thank you. I can.
Wonderful. Yeah, so my name's Peter Gilbert. I live in Sheffield, in one of Sheffield's traditional early 20th century terraced houses. My house was built in 1905. It's a mid-terrace, solid brick walls. And I guess that's a pretty standard old house for Sheffield. And we hear a lot about heat pumps not being suitable for old houses. So when I started with my house, I needed to renovate it fully because I needed to basically take it back to brick. It had been a student digs for a couple of decades before I moved in, and it was in a pretty bad state. And so as I started renovating it, I really made stuff up as I went along. I didn't start out with an architect or a heat engineer giving me a clear plan. I just kind of did research, and I didn't start out with the idea of a heat pump, but it came along as I started to learn about different eco methods. Now, I guess the first thing of all of that part of the story is that mine's an old house, and if it can work in an old house like mine, I really think it can work pretty much anywhere in the UK. I took it back to brick, and then I started insulating my home. And one of the first problems that I had with my house was dampness. So then I started learning about things like lime plaster to help the house breathe. So I actually installed internal wall insulation with a mixture of hemp fibers and lime plaster. I put that to a depth of about 30 to 40 millimeters on the internal walls, well, the external facing internal walls. That was a really interesting part of the process. And it did remove the damp problems that in many homes is to do with the walls not being able to breathe properly. Then, if you look at the first slide, the reason I've got this up is it's so important to start at the top of your house. And again, this is regardless of whether you're going to be heating your home by a heat pump or heating your home by gas. You need to start at the top of your house. That's where you're losing the most of your heat. It's like going out for a winter walk. You're going to put on a hat, aren't you, to keep yourself warm. So start in the roof. In my house, I put these layers of shiny space age super quilt. The reason I did that is because I have a small loft space, and super quilt allowed me to get the building regulations insulation levels without too much lost height, because it's very thin stuff. It's a bit uncontroversial. I mean, it's a bit controversial. It's a bit different to the way other people do it. So it can be hard to get the EPC surveyors to understand what you're doing. It did take me a few attempts to explain to them what I was doing with that, but eventually I got it passed. Then if we go to the next slide, Zizi.
Right, yeah.
Thank you. So I'm just checking.
You're muted, Peter.
You've suddenly muted yourself.
Sorry about that. So in between
We just heard you say, I'm checking, and then you went silent.
You know, I think that I'm experiencing some techno problems. I'm hoping you can still hear me.
We can.
Yes, we can now.
So in between my walls, I did a lot of insulation as well between the stud walls. This was partly to reduce sound, but also to do with heat. I wanted each room in my house to be a bit like an individually isolated room. So if you're not in a room, why do you want to be heating it? Why not separate all the rooms, a bit like airlocks or bulkheads in a submarine? That way, you're only heating the rooms you're living in at that time or on that day. And then you can do things with like TRVs, thermostatic radiator valves, so that you're programming each room separately. And you can also use zones of heating. So I have 2 zones in my house. I have the downstairs zone that heats separately to the upstairs zone. Could we have the next slide, please?
Are you seeing that, Peter?
I'm not yet, but are you?
Yes, we can see it.
Wonderful. So yeah, I've done a lot of home visits, inviting people from the community to visit my eco house, to visit the heat pump. I mean, some people think I work in the heat pump industry because I'm such an advocate for them, but it's not true. I just think they are fantastic. They are magic. And I think what Jeremy said at the beginning was pretty wonderful and on the point. The house doesn't know what's heating it. A lot of people say, oh yeah, but heat pumps, they don't work because you don't have good insulation, or they don't work because I've got an old house. It's like, well, it either works or it doesn't. You can either heat it with gas, or you can heat it with electricity, or you can heat it with wood. I don't recommend that, by the way, because you're just polluting your neighborhood. But it doesn't, the house does not know how it's being heated. So if you can heat your house with a gas boiler, you can heat your house with an air source heat pump. Whether that heat gets lost out of your house, that's another question, and that's to do with efficiency. But heat pumps clearly work. Everyone here today, whether they are homeowners or in the industry, have told your attendants today that heat pumps work. And the only reason they wouldn't work is if you haven't got the right schematics, if you haven't got a good installer who's done the right calculations for your home. So make sure that you get a good installer, make sure you do your research. Don't skimp on that. Don't go with the cheapest company, because yeah, then you might end up with something that's not going to work. But that could be the same with the gas boiler as well. You could end up with the wrong boiler for your house, just as you could end up with the wrong heat pump. So I'm just going to run through a few things. Sound, as Jeremy said as well, they're incredibly quiet. When I go out into my garden, I've got a small terraced garden, so it's not much space back there. When my air source heat pump powers up, I don't notice it much. But when my neighbour's gas boiler powers up, I hear that. But no one goes around going, oh, gas boilers are noisy. We shouldn't install gas boilers, should we? Because, you know, it's the sort of noise you just don't notice. You do have to consider a few practicalities, especially in small areas. You have to have a heat pump at a minimum of 1 meter from the boundary of your property. So in built up areas, obviously that's going to be a challenge for some people. Some people say they're ugly as well, having a massive air conditioning unit in your garden at the side of your house. Well, but you can get covers to go over them, and that will make it more attractive. Now, people are always wanting to know about the costs. So I'm not really into that sort of element, all the sort of facts and figures and the bills and stuff. To be honest, I don't pay that much attention. I know it's not costing me too much, because otherwise I would pay some attention. I'm a Yorkshireman after all. Mine cost about 12,000 to install the air source heat pump and the cylinder. So the whole air source heat pump installation cost 12,000. I had to spend another £1,000 doing all the new radiators. So as been said before, you probably want bigger radiators than you had before. You don't need to have them, but you probably will want them, certainly in some rooms. So I spent about £1,000 putting new radiators in all my rooms. So I've got double panel in almost all the rooms, and then I've got triple panel in the living room. But that sounds a lot, right? 13,000 for a new heating system. And obviously, if you're comparing that with a gas boiler that might cost like 1 or 2 or 3 grand, depending on the model, it's a lot of money, right? But no, because the government gave me £5,000 up front. So you take away that. And then I've got from the renewable heat incentive about £7,000 over 7 years. So I know that that's not straight away, and you need money in order to be able to start on that process. But if you look at those figures, I spent about 13,000, and I got given by the government over the period and up front about 12,000. So actually, it's costing me £1,000 to have a renewable heat source in my home. I'm off gas now. My gas is capped. £1,000. Well, I wouldn't have been able to get a new boiler for £1,000. So I'm quids in, aren't I? Does it work? Yes, 100%. I have hot showers. I do my washing up. It's hot. The other 2 people who live in the house with me, they have hot showers. They do the washing up. We're all happy. No one ever complains, oh, you know, there's no hot water. Oh, it's cold. You know, it works. It's fine. It's a bit slower maybe to heat up a room if your radiators are set to 50 degrees, 45 degrees flow temperature instead of, say, 70 degrees that often gas boilers are set at. And that reminds me, you can do a quick test tonight to see if it's going to work for you, a heat pump, without doing anything to your radiators. On a cold night, and yes, we're going to have cold nights quite soon, turn your flow temperature on your gas boiler down to about 50. Leave it like that for a day. And if your house is still warm, well, it turns out you could have an air source heat pump, because that's the difference. I'd love Jeremy to comment on that, but I think that's a good way of testing if your house is even heat pump ready already. Someone else mentioned the efficiency. So yes, gas is 3 to 4 times cheaper than electricity, but an air source heat pump is 3 to 4 times more efficient than heating your house with gas or direct electricity. So it's the same price. The running costs should be the same or cheaper. I've got an Mitsubishi EcoDan 8.5 kilowatt unit. When I first got the sizings done, some shoddy companies suggested I needed an 11.2. When I got a reliable company, they said, no, you don't need that. That's overkill. And they were right. I've got an 8.5. It's working fine. Don't go for the big shiny thing. Big is not necessarily better for a heat pump. I've got a 250 litre cylinder, and that's perfectly fine for the 3 people living in my home. Sorry if I sound like a bit zealotic about heat pumps, but I really do love them. I can't stand it when things like the Daily Mail bring out another story about how evil heat pumps are and how they're going to destroy the world. It's rubbish. Heat pumps work. They're efficient. They're the future.
Thank you.
Thanks for your time.
Thank you very much, Peter.
Oh, I've got 2 more slides, but you can run through them quickly.
Okay. Oh, that's the Yorkshire Post, which you've told us about. And the Tribune. It's good that you're getting in all the papers. So I'll stop sharing. Thank you very much. Very interesting.
Thank you.
Now for questions, well, I'm going to ask everyone to use the electronic hand. So if you take your cursor to the bottom of the screen, a little bar pops up. And then if you go to the icon called React, which is a heart shape, then the second from the bottom is raise hand. And you click on that, and the hand comes up like this. And then when you've been called to ask your question, you can lower it manually later. So who would like to start by asking a question? Oh, Julia's got something.
No, I just wondered, do you want to do questions from the floor to begin with, or should I have a look at chat and read out the questions there? It's up to you.
Let's start with questions from the floor.
Okay, fine.
And then, well, actually, we could alternate. You could do one.
All right.
And then, no, I'll have a question from the floor, then you, and then question from the floor alternately. So
Okay.
John himself has a question. What's your question, John?
Couple of comments. Peter mentioned the RHI that he's getting along with the grant. And Jeremy might be able to confirm or deny this, but I understand that there is only the grant available now, which is now £7,000.
7,500.
7,500. But the RHI
Is
that
finished.
comes with every 70 is gone. Yeah.
Correct.
Yeah.
That is closed to new entries. So the yes, the mechanism is the boiler upgrade scheme bus, and yes, you get £7,500 at the point of installation. Effectively, we do all the administration. If you had, let's say, a £15,000 heat pump system, the way most installation companies work is we invoice you £7,500. And then we draw down from Ofgem the bus grant, so you don't have to pay the whole figure up front, and that is knocked off your bill effectively.
Right. And the other thing that I was going to mention is that no one's really mentioned that we've all talked about the economic motivation, and the demotivation of perhaps the house. But I got a lot of motivation out of just doing the right thing. It's the right thing for the planet. We've got to stop burning fossil fuels, and oil is terrible. Gas is not too bad, but it's a lot worse than electricity. We ain't going to solve this problem if we keep burning fossil fuels. So electricity is the only way to go. So you've got a choice to do it, pay once and get 3-4 times the amount out of it, or just pay once and get once out of it if you've got resistive heating. It's a no-brainer. We've got to do it. And I think that in the future, it's going to become more and more difficult to sell houses, to let houses, if they don't have a decent performance certificate, which the heat pump will give them. So there are financial benefits, even if you do find you're spending a little bit more on the heat pump.
The biggest single thing you can do to reduce your carbon footprint is to decarbonize your space heating and hot water. I think it's on average something like 3 times the carbon saving you get from replacing a diesel with an electric car. So yeah, it's very significant.
Thank you. So Julia, do you want to do a question from the chat?
Yes, I'm looking at the first one in the list. That was by somebody called Julie, and I can't pronounce her name. Wojtniczka.
Actually, shall we ask her if she'd be willing to ask her question herself?
Again, yes. Julie?
That was me, Julie Wojtniczka.
Yeah, thank you.
So my question was that we're going to have an air source heat pump put in. We have got a wood burning stove, which I really love aesthetically. I really like the feel of it. I know you shouldn't burn trees. So the question, me and my husband have disagreements really about whether when we get the air source heat pump, we'd be ending up turning it off and on, or whether you just have the air source heat pump on all the time and very rarely use the fire. So it's that kind of balance really. And so the question is around that switching on and off and thermostats. Jeremy's answered me to a degree on the chat, but I'm interested.
Heat pumps are a lot smarter than boilers. So typically you've got a room sensor, a sort of somewhere central in the house, typically in the sort of hallway, but a central location in the house, which is monitoring the general sort of temperature. The heat pump's also going to be monitoring the outdoor temperature. So as it gets colder outside, it increases the flow temperature to keep a stable temperature internally. It's also measuring the temperature of water that's coming out of the heat pump into the radiator system and the temperature of the return. So if the water's going out at 40 degrees and coming back at 25, it knows it's losing a lot of heat into the house. If it's going out at 40 and coming back at 38, it knows that there's not much heat loss in the house. So it's all computer controlled. And generally speaking, once you've commissioned the heat pump and set it up, you can leave it to its own devices and it will just keep ticking over and adjusting its parameters as required. If you've got a wood burner, for example, typically you'd have a thermostatic radiator valve. I think it was possibly Peter was talking about those earlier. So the TRV is going to turn off a radiator in a particular room when it gets to whatever temperature you set the dial to. So you've got a lot of control in that respect as well. So if you have a spare bedroom that you don't use very often, knock the TRV back. If you've got, if you're in the kitchen cooking and the cooker's giving off a lot of heat, again, that will be picked up by the TRV and it will turn the radiator valve off. So yeah, it's pretty flexible. If you've got underfloor heating, again, you can put room stats in and do all sorts of specific controls. So yeah, you can maintain levels of comfort basically however you want it to be throughout the house.
Thank you.
Thank you.
So John, would you like to ask the next question? You're muted, John. You'll need to unmute.
Have I still got my hand up?
No, this is
No,
another
not that
John.
John. There's another
right.
John
Okay.
who hasn't put his surname in, so I can only call him John.
Okay, he's all right now. He's unmuted. Oh, John, we still can't hear you.
No, you've muted yourself now. Try unmuting again. That appears to be unmuted, but we're not hearing you. That's odd. Do you want to look into your audio settings? And while you're doing that, I'll take another question and come back to you. Do you want to Julia, who's the next question from the chat?
Yes. Can Roger Haig indicate he's there, because he had a question? Roger Haig. Right, shall I read it out? Cece?
Okay. Yes.
Right, he says, we are in a 30s brick-built semi with minimal insulation and a 15-year-old boiler. We also need to refurbish our bathroom to assist my wife who has mobility problems. Where do we start? Is there a company we can contact to project manager start to finish through all the work involved without us going through separate insulation heat pump installers, bathroom companies, and who can help us with the grant funding?
What he needs is a retrofit coordinator. That's a bit off topic for today, but if he has one who's PAS 2030 standard, or the other person in the Sheffield area is Nick Parsons, who isn't bothered to qualify because he gets so much business without. He's highly recommended. He's been doing these things for many years, and yes, either one or the other would give you loads of help and advice and project manage.
Peter Gilbert, you've used Nick Parsons, haven't you? Could you say anything about him or how to contact him?
I've no contact. I've never had any contact with Nick Parsons. I'm sure he's a fine, upstanding fellow. We were in an article the same, but we weren't in any way linked in the article.
Right.
But
I'll
you know,
look
if
up
you
his
go,
email and we can put that in the chat.
Yes.
If you go to, if you Google sort of architect firms that also do specialize on retrofitting, they might be able to help that sort of thing, because it looks like this couple need somebody who's going to design the home for them.
Yes, Nick, I think is called Sustainable Building Sheffield. But anyway, I'm going to put his email address in the chat. Where's chat?
Okay, in the meantime, John, are you unmuted now? Who was... Cece, shall I do another question? Okay. Oh, you're right now.
Yes, yeah. In that case, is John okay? No, we're still not hearing you.
No, it's strange, isn't it?
Okay, well, shall I ask a question? I've got a friend who got 3 quotes for a heat pump system for his house, and in different ways they were all over specified, and it was only when he got the 4th quote that he felt the person really understood what he needed, and he took that person on. Is that just bad luck, or is that quite typical that they over specify?
It's quite typical, actually. Any decent heat pump company should be working to the microgeneration certification scheme design standards. And part of that is carrying out a very detailed room by room heat loss analysis. That in itself is, at the very least, probably a couple of hours of work. It's relatively complicated. You need to know a fair amount about the property. So a lot of installers will put a finger in the air and say, well, it's probably a 12 kilowatt heat pump. You can make some assumptions. A new build property these days, to current building regulations, the average heat loss per square meter is about 30 to 35 watts. So you can multiply that by the floor area and say, well, it's roughly speaking, it's a 6 kilowatt heat pump or a 10 kilowatt heat pump. And a lot of people will work on that basis until they get a deposit, at which point they think, right, now I'm going to do the actual heat loss calculations, at which point the specification might change. So yeah, you've got to be a bit careful who you're talking to. We tend to do the heat loss calc. We've got a dedicated heat loss assessor. All our salespeople are trained to do heat loss calcs. So yeah, it's finding an installation company who are prepared to do that work at the outset. Well, certainly we don't charge for that. And then we know from the beginning what size heat pump you need, because that's really the only proper way to do it, is to properly understand the building and what the requirements are. What you tend to find, most heat pumps these days have what's called an inverter-driven compressor. So the compressor can speed up and slow down. So the thermal output will vary between maybe 3 and 12 kilowatts. So if you haven't got the heat calculations exactly right, there is a bit of leeway in that heat pump to provide a little bit more or a little bit less heat. It's not a very good way to design a heat pump system, relying on that modulation in the heat pump. So really, yes, certainly always use an installer that is registered with the MCS. If you go to Microgeneration Certification Scheme, mcs.org, I think it is, there's a list of accredited installers on there. So yes, that's your first port of call, getting an MCS accredited installer. They should be doing all of that design work.
He'd already done the test that was mentioned about running his boiler at 40 degrees on the coldest day in winter, and yet the first people to quote weren't taking any interest in that. So thank you. That's very helpful. Now, Julia, could you read out John's question?
Yeah, I think Jeremy just wanted to add something. Jeremy?
Oh, okay, yes, do.
I was just going to say, on the question of running your boiler cooler, it's a reasonable first pass. But again, any MCS accredited installer should be doing an empirical assessment of each of your radiator outputs relative to that room, rather than just a bit of a wing and a prayer. Well, it kind of works with a boiler on a low temperature. So yeah, it doesn't tick the box for the MCS sign off. We wouldn't be able to sign that system off just on the sort of anecdotal evidence that it works when the boiler's turned down. You do have to do all those calculations.
Okay, thank you. That's helpful. So now I'll hand over to Julia to ask John's question.
Right. No, not John now. This is Gwilla.
No, but John, who wanted to ask a question, says he's
able to do it now. I can't see him. John?
Yes, he couldn't speak, so he put, let's see if I can find it in the chat.
Right,
here.
shall I?
He says, I'm sending a message as you can't hear me.
Right.
Should you locate a heat pump as close to where your gas boiler was, you need to have a hot water tank. So where should that be located?
Very much case by case. Where your gas boiler used to be is the existing distribution point for all your pipe work that goes off around the house. So if you can locate the cylinder near there and the heat pump outside near there, so much the better. However, that is probably the case in 50% or less of the time. So yes, inevitably, for some projects, we have to redesign the pipe work to some degree. Cylinders can be located in all sorts of places. We occasionally even put them in loft voids. It's very case specific. So if you've got a utility room that has the gas boiler in it and it's got a nice wall outside where you can put the heat pump, brilliant. But yes, it is very much case by case, so we have to assess that individually.
Thank you.
So, thank you. Julia, do you want to ask another question from the chat?
Yes, this is Gwilym. You're there. If you'd like to unmute, tell us what your question about Legionella's disease and the problems with that.
Okay, 40 years ago, when I was much younger, I used to work for a company called Carrier Distribution, which is, well, you know them. And it was at the time when Legionella problems were like the big headline, because you had to take the temperature above 60, otherwise people die. I think you've answered it in the chat room. There's a cycle on the heat pump that takes the temperature above 60 to kill off any chance of Legionella. The other thing I wanted to ask was, is it better for the heat pump to be in the shade?
Okay, I'll start with the Legionella. There has never been a recorded case of Legionella proliferating in a domestic heat pump in the UK. However, you do have to, the Health and Safety Executive produce guidance on Legionella protection. It's certainly not something you want to risk. The guidelines are that, yes, we have to take the stored water temperature up to 60 degrees for over an hour once a week. So that's built in, that's an automatic program in the heat pump. Modern air source heat pumps, particularly ones using natural refrigerants, can produce anything up to about 65, 70 degrees C without using an immersion heater. So that can be done relatively efficiently these days. So yeah, that's all built in. Second question, heat pump in the shade. Really, the external location of the heat pump is not as important as you think it might be. A lot of people think that you need to put them on the south side of the house because it's going to be warmer, which actually isn't true. On the south side of the house, you'll be getting solar radiation, infrared radiation on your skin, but the air temperature is actually going to be the same as it is around the back of the house. Okay. No, the most important thing for locating the outdoor units is making sure it draws ambient air in at the back, takes the heat out of it and blows cold air out of the front. Now you've got to make sure that cold air has room to escape, because you don't want it getting...
You need plenty of airflow. Basically.
Ideally, yes. I mean, it's not a huge amount. Typically about a metre in front of the heat pump is enough to get it to dissipate. But you want to avoid putting them in enclosed spaces that can effectively sort of fill up. If you've got a small backyard, let's say it's 2 meters. Or a
canopy over the top or something.
Yeah, yeah. So yeah, avoid restricting the airflow too much. That's the critical thing.
Okay, thank you.
No problem.
Now, there was a person with their hand up.
Yes, there was somebody called Tim. Are you still there, Tim? I've just looked on chat. He's not written his... Is he gone, perhaps? I don't know. No,
maybe he had to go.
Yeah.
That's a shame.
Right, so it's up to you. There's John's in line now, so...
Yes, although he's asked a question, I'm wondering if I should allow people who haven't asked questions to have a... Oh, John's saying please. Okay, go for it, John.
You need to unmute.
You need to unmute.
Yeah, sorry, I'm jabbing at buttons. Yes, thank you very much. I have a situation where it would be very much easier for me to mount a heat pump inside the building and duct in and duct out. I've got the opportunity to put a very large duct in and out and mount the thing inside a utility room within the house. Is this, I presume this is not feasible at the moment, Jeremy. Is it something that we could negotiate?
You will not get a manufacturer to warrant their heat pump under those conditions. It's been mooted a lot of times. Gwilym mentioned Carrier. I used to work for Danfoss, and they white labelled a number of Carrier products, and they did a specific ducted heat pump. It's a commercial machine, that was designed specifically for that. But the typical domestic consumer machines, no, the manufacturers are not prepared to warrant the system if it's ducted.
I mean, if I'm prepared to take the hit of not having a warranty, what about the MCS grants, the boiler replacement grants?
Technically, I mean, the thing to bear in mind is a 10 kilowatt heat pump running at full blast is going to move 4,500-5,000 cubic meters of air an hour. So yeah, the ducting in and out has to be.
I've got a window which is 1 meter by 0.5 meter on 2 walls that I can get in and out.
Right. Yeah, I mean, if you've got the heat pump right up against the window and it's just, yeah, I mean, that's
yeah.
Potentially...
Okay. What I was nervous about is falling foul of the grant system and having to pay an extra $7,500.
To qualify for the grants, the heat pump has to be MCS certified. So as long as it meets the design standards for in terms of providing enough power, then that should be fine. Yes, you might.
So I just have to persuade someone like yourself to do the work for me and sign it off MCS.
Yeah.
And then I'm on my own. I'll have to go.
Essentially,
Good.
yeah.
Okay, thank you.
Okay, is there any more questions in the chat, Julia?
There are. Just once again, I noticed Dave Speak was in the line to ask a question. He's gone along with Tim. Is Dave Speak still there? Okay, I'll go back to a question in the chat. This is from somebody called Ian. Ian, are you there? You had a question for David.
I did. David, I see you had a 10 kilowatt heat pump. I'm guessing with one that size, you'd have needed planning permission because it's over the permitted development levels. Did you do that yourself? And what was the process like? How easy was it?
I live in the Peak District National Park area and tend not to ask about planning permission. So, yeah, I didn't ask is the answer to that one.
Oh, well, I'm surprised your installer actually installed it without seeing the planning permission, but Jeremy might want to comment on that.
Well, it's not up to the installer to apply for planning permission. It's the homeowner whose responsibility. So we personally have a sign off that by signing our order contract, you're confirming that you have applied for all the necessary permissions. I would say planning authorities these days are much more aware of heat pumps. If we go back sort of 15 years, the Peak Park particularly were very twitchy about heat pump installations. It's not like that anymore. We are currently working, the permitted development requirement is that anything over 0.6 of a cubic meter needs planning permission. That is a hang-up. It's basically legislation inherited from air conditioning. It's a total nonsense, frankly. It's a thorn in the side of heat pump installers. If you want a heat pump to be quiet, you want to be able to get some insulation into it, which means it needs to be bigger. The consultation period is finished on that. We're expecting that to change fairly soon. So I wouldn't expect that to be a requirement for permitted development. I mean, I don't know, it's sometime in the next 6 months, let's say, we'd expect that to change. So.
Yeah, I'm just about to go through it, which is a bit of a pain, but I have been contacting them, so they know I'm going to do it, so I have to go through it. But it turns out I actually already have another heat pump. I have a small air conditioning unit, so that's counted as a separate heat pump, so I would have to have one anyway. Yeah. I just wondered if anyone had gone through it and decided the pain, but I guess I'll go through it and find out.
Good luck with that. I'm going to take one more question and then I'll give Peter Burgess-Allen a slot. So this is advanced warning, Peter. Next in the queue is Michael.
Good evening. I understand and agree with the MCS principle of designing a heat pump system for the house and not for the household. because households can have strange and aberrant behaviour. The strange and aberrant behaviour of my household is that we prefer not to have the house heated at night, even in the coldest weather. And I wonder whether there is a case for storage, because at night, when we don't want our heating on at all, is the time at which the grid is operating at its lowest carbon intensity. And if we could store heat gathered during the night, or store the electricity that we could, which of course is high grade and is more flexible, then there's quite clearly a carbon footprint benefit from doing so.
Yes.
However, if we store electricity, we probably need to have a larger heat pump in order to have the capacity to bring the temperature back up the next day within a reasonable time. But if you were to make it as a thermal storage and maybe a phase change storage material, that would give us the opportunity to do that without having to upgrade the size of the heat pump. Have you ever explored these options, and what conclusion have you come to?
That is a very timely question. I am involved in a trial with Energy Systems Catapult, who have pledged, I think, about £10 million towards exactly that question. There's a company called Sunamp who produce phase change hot water cylinders and thermal stores. And yes, the demand side loading question is something that is very prescient at the moment. So I'm about to have one of their Thermino hot water systems put in, but externally a very large heat store which will do exactly what you've just been talking about. It's in the trial stage at the moment. They're running that until the end of March and collecting data, but I would expect within the next 12 to 18 months, those products will be going to market. So yes, it's very much on the minds of policymakers and manufacturers. So yes, a very prescient question.
Can I please just jump in and make a comment on that? You're sort of implying from the question that the heat pump doesn't work well reheating. It has to be on at a low grade all the time, and that's nonsense. I turn mine off a lot of the time. I like a cold house at night time. I do not have any problems at all with turning the heat pump on and it gets warm. It's not.
Yeah, there's a thermal inertia is what we call it. Once the heat pump has got all the building fabric up to 18 degrees or whatever you like it in the day, if you turn the heat pump off at night, and lots of people do this, I do it as well, let the internal temperature is likely to only drop maybe 3 degrees. It feels quite significant, but it's not a huge amount, and it should be no problem for the heat pump to pick that up again in the morning. So
I operate on the principle that I have a low thermal inertia because I like things to be able to move quickly. I like it cold at night time, so I've chosen to insulate the inside of my walls and not have big thermal mass storage.
Can I come back with a rejoinder there? You can't defeat the law of physics. If you only have your heat pump on for half the time, it will need to be a larger heat pump in order to deliver the same amount of energy.
My heat pump easily copes, and it's half the size that they wanted to put into the building.
Partly that is down to the microgeneration certification scheme design standards. So we have to provide a heat pump that will provide 100% of your heat requirement, typically when the outdoor temperature is about -4. It depends on the location. So there will be sufficient capacity to do that in very, very cold weather. So more typically when the nighttime temperature is, let's say, 2 or 3 degrees, that heat pump has overcapacity built into it, into the design. So generally speaking, yes, I understand what you're saying, but what you don't want to do is put in a heat pump that is much too large for the property generally. At their lower end, it's a little bit, basically, you don't want the heat pump turning on and off and on and off, short cycling. If the heat pump is too large, that is a danger and it will reduce the lifespan of the compressor. So there's usually a midpoint to be found. But yeah, it's a valid point.
Lovely questions. Thank you. Oh, I was going to have Peter.
Peter, yeah. Peter Burgess Hill, Burgess Allen, Peter from MEA.
Hello, hi, good evening, everyone. Thanks for giving me a little slot here. I won't go on too long. I think some of you have already seen some of these slides, but before I get into that, I just thought I'd do a little plug for another webinar that we've got coming up on the 25th of November. So it's a little way off, and it's around dealing with contractors and talking to those people that you might need to talk to around the questions that you might ask. So if I can just perhaps pop a link in the chat, if you're interested, please do sign up for that too. That would be great. Yeah, getting retrofit done well, selecting and working with contractors. So I think it might be really useful, particularly if you're on the brink of doing some work or getting a heat pump or whatever it might be. And then the other thing I just wanted to quickly talk about, I've got just three or four slides very quickly around a project that I'm involved with. We've got some government funding. Just try and find how I share my slides. Yeah. So yeah, it's a government-funded scheme. It's known as Local Energy Advice Demonstrator, which implies that that it's a sort of a pilot project that we're doing. So yeah, we're running it alongside Nottingham Energy Partnership, and the essential gist of it is that aiming at homeowners, particularly in harder to treat properties, which by the sound of it, many of the have described similar, solid walled homes and so on, conservation areas. And if you're just in a poorly insulated or a D-rated or worse property, those are the three kind of criteria really. So it can be any one of those things. And the main thing we're offering really is some free retrofit assessments. So this is the sort of the PAS 2035 process that was referenced earlier around home energy assessment. So they're quite technical surveys of the home. Generally cost about £600, I think, on the market. Because we've got some funding coming through, we've got a few of these. We've got about 30, 40 or 50 of these still available. So keen that that people come to these if they're interested. I think it would be useful. Help to sort of prioritize what you need to do. What's the best thing to do? Is your home, do you need more reassurance around a heat pump, or are you adequately insulated and that sort of thing? So quite a personalized report coming out of that. So nice and friendly, hopefully not too technical, and built around what we've understood your priorities might be and your budget and so on. So the way to apply for that will be through that website address there, which I'll pop in the chat. And if you're quick with your QR code reader, you can use that QR code on the screen to find the page. And essentially just register on there. We can have a chat with you, and if you decide that it's not quite what you wanted, then by all means you can tell us that. But otherwise, it shouldn't take too long for us to get out and sort out a survey for you in the next few weeks. So hopefully that's of interest to a handful of you. We're really pleased to hear from you.
Thank you.
Try and stop. Yeah.
Thank you. And while we're at this point, would Lisa like to talk about her webinar that's coming up next week?
Sorry, I wasn't expecting that. Yeah, I put it in the chat just to say this will be the third in the series of Eco Homes webinar. It's next Tuesday, same time, 7 o'clock, and it's on solar PV and batteries. So same format as today. and the registration link is in the chat. Thank you, Zizi.
Great, thank you very much. So I'll take another question, and then Julia can talk about the open homes in a minute or two, or maybe I'll take another 2 questions or so.
Yeah,
So Richard, would you like to unmute and ask your question?
Yes, please. Can you hear me?
Yes. Yes.
Okay, I did put it in the chat. I'm just about to buy a 5-bedroomed Edwardian house. It's detached. It's on a hill. It hasn't had any work done on it for many years. The boiler's been condemned. From my viewing, there's not much sign of any insulation in it. So this is a fantastic opportunity to future-proof it in terms of energy efficiency. So it has got a very large south-facing roof, or half the roof south-facing. So an opportunity for maybe some solar in there, but I've got no idea how solar could work with a heat pump, or if that's possible, or what the preferred or advice is, what to look at first. So I'm just looking for any pointers and steers on this big project I'm going to be taking on.
Storage is probably the key here. Generally speaking, when it's nice and sunny and you're generating lots from your PV system, there's not an enormous heat load in the house. So some storage is generally, you know, battery system is a good idea. There will be a net improvement, you know, from installing the PV system. It's difficult to quantify precisely, but I know certainly anecdotally we've got a project in Buxton, and the homeowner there is, I think his electricity bill was something like £7 a month or something crazy, because he got a big PV system and a big battery system, and it's doing nearly all of his heat pump consumption. So it certainly can be done. We don't actually install PV, so I don't want to stray beyond my my area of knowledge. One thing we do quite commonly is on the hot water cylinders. There's a company called My Energy who produce a box called an Eddy. And if you're not consuming the electricity from your solar panels and your batteries are full, you can divert that electricity to an immersion heater in the hot water cylinder and generate some free hot water. So that's something we do quite commonly. But yes, it's probably worth speaking to a solar installer to see what they can offer, and yeah, we can tie into some degree.
Just a supplementary, one of the other things we're probably going to have to do is rebuild the lean-to garage at the side of a property. At the moment, it's got a dodgy old roof, and I was just wondering, would it be possible to install a heat pump on a suitably strong garage roof?
Yes, is the short answer. There are some planning implications currently with the planning system. What I would say is that it's going to cost you an amount more to install, because we've got to get a load of lifting equipment. Heat pumps weigh anything up to sort of a couple of 100 kilos. So you need specialist lifting equipment, and we will be working at height, so you've got to get scaffold and all the rest of it. But yes, in theory, it can be done. Also, your servicing costs will be higher, because we've got to get scaffold in once a year to get up there and service the thing. So I would say ground mounting is preferable, usually, certainly from an installation perspective.
Yep, early days, but that's good advice, and I'll be taking that into consideration. Thank you very much.
If you're starting from scratch, Richard, because nothing's been done for many years, you're highly recommended to do the insulation first. It will be cheaper and save more climate change, more carbon, to insulate first, then do the heat pump, and then do the solar last. Many people do it the other way around, but actually you're better off starting with the insulation and then the heat pump, as I say, and then the solar.
Okay, that sounds a good sequence to me.
Just one
Julia.
thing.
Oh yes, Jeremy.
I'll just butt in quickly. Yes, because we have to do a heat loss assessment for the property, we can advise on insulation as well. So if you are proposing, do I put double glazing in, or do I spend a bit more and put triple glazing in? Well, we can quantify what the effect of that will be and model how that's going to affect, the heat pump size and your running costs and things like this. So we like to get involved quite early on in that process, because we can advise on that and help you decide what are going to be the most cost-effective measures to implement.
Okay, it's a blank canvas, really.
Great.
Thank you.
It sounds like having a good firm like yourselves makes a huge difference.
We'd like to think so.
Are there any more questions in the chat, Julia?
Yes, there are a few. I'd rather do the questions first, because people have been waiting, rather than talk about.
Okay, so I'll take Bruce next.
Oh, okay, do that, and then I'll do one.
Oh, okay, sorry, I've misunderstood what you're saying. Let's have
Okay,
Bruce.
so is Peter Gilbert still here? Peter Gilbert?
Hi there.
I beg your pardon, sorry. I'm sorry that you're answering the question here. Sorry, it's somebody called Martin S. Martin S.
Okay.
Are you there?
Yes, I'm here.
Right. You've got a question about maintenance requirements.
Yes, it's just I just wanted to know, roughly the cost of maintenance for a heat pump. I understand it's a yearly visit. Is that roughly the same as a gas boiler service?
I would suggest that Jeremy's the best person to answer this. I'll be honest. When I said that getting an air source heat pump serviced is just the same as getting a gas boiler service, what I meant more is it's easy to shop around and get somebody to service your air source heat pump, just as you would need to get your gas boiler serviced now and again. But Jeremy will know about the prices.
We typically charge about £250 for an annual service. Most manufacturers require that the system is serviced annually to validate the warranty. Beyond that warranty period, it's up to, typically we probably move to once every couple of years after that. But yeah, it's generally the primary motivation is to get that warranty validated.
So
could I just jump in there, because there was a question that's related to that. Somebody called Nikki has said, are people going to the manufacturer for servicing, Jeremy? Or can they?
Depends on the manufacturer. Valent, for example, have a huge fleet of mobile engineers. They're training up more and more heat pump people. So yes, I imagine that will probably become the norm, in fact, going forward. At the moment, most heat pump manufacturers are, the likes of Valent, because they've been doing boilers for so long and they've got an established staff of mobile engineers, they're in a position to do that quite quickly, but it does depend on the company. So yeah, I think it depends.
I was going to say, I am Nikki that asked the question. We've actually got a Dakin heat pump,
right?
And I'm really struggling to find anybody other than the manufacturer that says they'll service it.
Yeah. So we have never installed Dakin units, so we wouldn't know our way around the machine to service it. So that's probably, I imagine that's fairly typical of any installer who doesn't know the kit probably won't want to service it. So yeah, you may struggle. Dakin's a well-known brand, so you'd assume that there were people around who would be able to do that. But yes, it's not something that we do, I'm afraid.
Oh, it's interesting that it's not like just being registered for Corgi for gas, that all of them will do each other's.
Can I just say that I've also struggled with servicing, and I've been to Valent I've gone back to them because I couldn't find anybody else to service my Valent boiler, heat pump. So,
there can be, I mean, IMS don't actually service installations that or systems that we didn't install. I don't know. Well, actually, there's a guy I do know a company, H2O. They're based in Stockport, but they do cover the Derbyshire region. And I know John, a chap called John Glanfield, I believe he will service pretty much anything. So he's geared up. That's his core business is service and maintenance rather than installation. So there are people around, but yes, certainly.
Yeah, they're much more interested in installation than servicing, unfortunately.
That's interesting. Thank you both for sharing that experience. That's really useful because once you've got it installed, you do need it serviced, don't you? So John's got his hand up again, but I think
we've got I've got no more questions here at the moment. It's nearly quarter to 9. John's, so we could take John's question.
Or do you want to talk about people opening their homes?
I'll maybe let John. It seems only to be one more question.
I've got a very brief question just to Pete. Once the 30 to 40 free allocations have run out, is it possible to buy an assessment from them?
Yes, possibly. Yes, we could possibly talk about that. Yes.
Okay. Is it something? It's obviously something you haven't done before, so you don't know a price or.
Yeah, it's not really our core business, but we've kind of skilled up people. We've got a subcontractor that we're using who's very good, so I'd be quite happy to recommend him. And so I'm sure we can.
I know a lot of the heat assessments that I've done around the valley, people would love to be able to have a written down piece of paper from someone. They'd certainly pay money for it to get that done.
Right. Okay. Well, yeah. Drop us a line.
Okay, so that's great that even when, I mean, I think that was the hope that once the pilot had been done, you'd roll it out to everybody else. So it's great to hear that that may be the case. Julia, do you want to talk about the open homes?
Yes, it's very modest at the moment, but John here, who's obviously just spoken now, and Dave Locke and a couple of other people are willing to open their homes for you to come and see their heat pumps. I'll be sending details about this to you. I think, Zizi, we've got a list of all the email addresses of the people. I will be sending you details about that when we put it up on our website and in our November newsletter. It's really worth going, I think, to somebody's house. This is what we did when we came back from Germany and moved into this old house of ours, which was tumbling down. And we went to see people who'd done insulation and solar panels, and it really fired us up. And you can really ask a lot of questions just randomly while you're there. So I do recommend going. You really do learn a lot. Just can I also mention, looking into the chat, there's quite a lot of useful information from Lisa. Pete Burgess-Allen has also given details about this Getting Retrofit Well Done, this event that he's organising, and he will also give you information about these heat surveys, home energy surveys that he's just been talking about. So do look at the chat. Will the chat be available afterwards, Zizi?
If we save it, so we could save for chat and then you could send it out.
Right, okay.
With the email.
Yes, all right.
I hope it can save. Sometimes they don't.
That's all I wanted to say. Okay.
Okay. Well, I think we perhaps should wind up before we lose too many people, and nobody's got their hand up at this.
No, Oh, hang on there. I just checked the last messages.
I think
Yeah, I can't see any more questions. Has anybody got any more questions just before we wind up? Okay.
I'll take this opportunity while Julia's checking and up at this point because we are losing people. So
Yeah.
Thank you very, very much, everybody who's contributed. It's been a really lovely evening. There's been some really interesting questions, both about the technical side and the practical and the costs. And, you know, the practicalities of servicing. That was an issue I never thought of, but finding somebody to service. So thank you all for all the different questions. It's been really useful and interesting.
Yes, and can I add my thanks as well to all the people that's spoken tonight. Really excellent speakers. I've really learned a lot, and it's made me more even interested in getting a heat pump. I should be talking to my husband about it afterwards. Can you also notice Jeremy's offer for you to actually go to the IMS company showrooms, and you can get a lot more information from them there. I'm not pushing them as a particular company, but the offer is, or a company to use, but the offer is there again in the chat function. Okay.
Yeah, particularly.
Well, thank you.
Oh, Gwilym.
I was just going to say, if you're visiting the Dronfield event, which is a week on Thursday, if memory serves, if you just want to pop up and have a look at a heat pump in action, we're just up the road. So yeah, no compulsion to come and buy a heat pump, but if you just want to see one working, then yeah, by all means, drop in.
Okay, thank you. It's like
okay. Thank you, everybody.
Yeah.